Hello everyone, it's October 5th. Alright, let's do this. Swim in rising water. Okay, it's a tough question. We will stick to what we do, which is 15 to 20 minutes, and then if we can't, we'll call it a quit. Alright, swim in rising water. You're given n by n integer matrix grid where each value represents the elevation at a point. It starts raining and the water gradually rises over time. At time t, the water level is t, meaning any cell with elevation less than or equal to t is submerged or reachable. You can swim from a square to another 4 directionally adjacent square if and only if the elevation of both squares individually are at most t. You can swim infinite distance in 0 time. Of course, you must stay within the boundaries of the grid during your swim. Return the minimum time until you can reach the bottom right square. If you start at the top left square, so you start from here, you want to know what's the minimum time to reach here, and the only way to reach is you can swim from a square to another one, to adjacent square, if and only if the elevation of both square individually are at most t. So at time 0, like at time 1, so basically I can go here. At time 2, I cannot go anywhere. At time 3, I can go here, right? You cannot go anywhere because they are not the same. So basically at each time, they need to change. So you need to move. You need to move when the time increases. It's just like, and then once it reach, and it will continue reach. So basically it's just a barrier. At what time a barrier can be broken, which can be considered as a cost, right? It's just like a cost. The cost go from this is like 1, right? So you have a cost, and I'm thinking about Dijkstra, because in Dijkstra is the minimum cost, right? It's the minimum cost from one cell one node move to the other. And if you start from something and you have some cost, so you will go there, and then you will see from there where you can go, and then you will find the cost. So yeah, that feel like a cost type of thing. So I'm not sure if we can do it here, but like the cost of this is 1, the cost of this is a 1, and then here is like 11, and this, the cost is, because it doesn't, hold on, the thing is the cost will change, right? So, but when you reach here at a certain time, right? But if you reach something, yeah, the cost would change, but that's fine, right? That's fine. It's just the current cost. The current cost of moving here. So so the cost is the current water level and the water level of under the height of the cell. So if we go Dijkstra, and the cost is changing. So the cost of moving there, as time goes by, it actually decreases, right? As time goes by, the cost decreases. I'm not sure how are we going to represent that in Dijkstra, because Dijkstra, you start from 1, right? All the places you can go, and you have a cost. For example, you start from 0, right? So the cost of going here is 1. The cost of going here is 24. So yeah, I say you go here. But then this is time 1. And the cost of going here from here to here actually changes. It's no longer 24. It's actually 23, right? So therefore, in your queue, right, in your queue, you have to, so when you are in the queue, that is the initial, right? That is the initial cost of going from cell to the other cell, the initial cost, which is based on water has not reached here yet, right? And once you want to find which one need to go, you have to adjust the cost. You have to adjust the cost. Now the thing is, the cost you're getting right now is the current cost, but those are the previous costs. Now, this is a 50. Maybe this can give us some hint. For example, we need to adjust the cost. Something like that. Adjust the cost at every single step. Huh. So what do you mean by adjust the cost at every single step? So you're at 0, 1. You're at 0, 0, right? So what you're gonna push in is you're gonna push in. We have. Yeah, let's pop out. So we push in. We have 1 with 0 with 1's 0, 1. Right, and then we also have 24 of 1, 0. Right, that's what's in the queue initially. Right, so is the start, and then you move on. Then the total t. Now you go to 1. Right, so t now you go to 1, and you need to adjust this. So adjust this by we decrease to 0. This will be 23, and then this one get popped out. So now you're at 0, 1, right? You're at 0, 1, and you don't go back. Well, what's the point of going back? So you also need a way to like not do the previous. I can just set it to -1, which is perfectly fine. If you have visited, you don't visit again. So now you have 0, 1. So from 0, 1, from your point of view, right? What is the current cost of going here? Well, actually not from your point of view, it's from the time point of view. T is equal to 1, because when you reach here, T is 1. So the cost is 1, go to 0, 2, right? And then the cost is 22, go to 1, 1. And of course, you also have this. So now you move on to the next. So you next round, time plus 1, so T equal to 2. So you go in there, right? Just, pop everybody out, reduce this. So how do you reduce this? So the cost is 1, time is 2, right? Which just means the current height. See, this is the tough part, because this cost is from this to the current, right? Then you plus 1. So how do I adjust the cost for going here? Well, actually, no, because each one is plus 1. So you just, redo this and then minus 1. Not really minus 1. You check the front, right? Front is 1, which means everybody would do 1, right? We'll do 1. So we'll wait to times 3, and this one be 0, and this will be 21, this will be 22. Yeah, you just check the front, and you pop everybody out, and everybody will we'll grab this again, but we reduce that amount. It's just the amount of weight, because you have to wait until this get to 0, and then you push everybody back in again, and then you do it again, right? And you do it again. So every round you have to redo this, every round you have to redo this until you hit the bottom right. Okay, we can give this a shot. So we're 10 minutes in. We give this a shot and then see if it works. If it doesn't work, we'll copy and paste, call it a day, and then I can go eat my dinner. And yeah, that's kind of how the thing's going to go. So this is 778. We will use Dijkstra. However, since the cost of moving from one cell to another changes with time, at each BFS round, we need to adjust the cost. We need to adjust the cost based on how long we need to wait for the smallest cost cell to be available. Since the size is at most 50, right? Since the size of the grid is at most 50 times 50, we most likely can afford this complication for this readjustment. I don't know what's the runtime. I forgot what Dijkstra's runtime. I think it's vertex times edge. Probably O and tripled, my guess. Okay, so how are we gonna do this? We definitely need this, okay, and then we need I think I'll repeat what I've been doing. Say using coord std pair int. I think this one works, and then we need to get priority queue, which is going to be std pair, right, int and coord, and then this is pq. Okay, and then we say pq dot push initial cost is 0, and we'll get 0 and 0. This is what we start. And also grid 0 equal to -1. Does it matter what this value is? It does. So this is actually not 0. The cost of going here is grid 0, 0. This is the cost of going here, okay? And then because we visited it, we just do that. And we also have t. T is start with 0. And in fact, t is not starting with 0. T is starting with that's fine. Let's just do it this way. And so we're gonna return t. So while pq is not empty, okay, and we'll get to the top. We have to get a negative because we want the smallest, right? We want the smallest to show. Okay, so we say auto element equal to pq dot front, pq dot top, and we don't pop it yet. Okay, don't pop it yet. All we need to do, we get the top, and we'll find out the delta t. So int dt shall equal to element dot first, right, minus t. This is the cost to go there, or the minimum time you need to get there. So you do this, so you get the delta t, how much time you need to get there, right? So you know, then what? Then you just progress the time, right? You progress the time. You progress the time. So t shall equal to element first, right? So you progress the time, but then you need to update, right? So update all the cost, and int m, let's call it equal to pq.size. So what we're gonna do is for int I equal to 0, I smaller than m, I plus plus. So what we're gonna do is auto element equal to pq.top, pq.pop, okay, pq.push element.first plus dt. Right, so that is, and then element.second. So that is the new cost. It's actually not plus dt, it's minus dt. So that's the new cost, because you wait for the dt. You wait for this amount of time, right? And then you push it back. So we do it m times, so everybody gets good, right? And then we get a new t, right? We get a new t. Yeah, I probably should do it here. We probably should do it here. So t equal to this. Doesn't matter, we don't use t, we just use dt. All right, so now the top element is going to be, and then once we do that, well, can we just go, you know, pq.top, this, and then this is going to be a pq.top, so we don't need this, right? And then we are going to get it out. So we say cost. We don't really care because it's going to be 0. We don't really care what is its cost. So here also, like this dt, if it's the smallest, I don't think it's going to be 0. So now all we need to do is I equal to pq.top dot second dot first, and j equal to pq.top. Maybe we can do auto ij, okay, equal to pq.top dot second. Okay, so we get ij out. So we have a t, we have ij, right? So update all, and then pick the cell with no cost, right? With no cost to reach. Okay, so a little bit problem, because when you get a first, it is going to be a negative value. So we're actually going to have to go plus t, okay? And then t is going to be negative this, right? An element, that's fine. And then when you push element dot first is going to be a negative value, so it's going to be dt is a positive value, so we're going to say plus dt, right? Element dot first is non-positive. Okay, so then we got this one out. Then we're just gonna go, go around. So std vector coord dirs 0 1 0 negative 1 1 0 minus 1 0. Okay. So next is going to be for const auto dij of dirs ni I plus di nj plus dj if again 0 small equal to ni small n and ni small than this and 0 small equal to nj and nj smaller than n and grid ni nj is larger or equal to 0 because I set a -1, right? Yeah, when this is reachable, right? This is reachable, then we're gonna push in. So the cost, right? We need a current cost. So the current cost is going to depend on the cell height and current t, right? So we're gonna say pq.push, okay? So the current height is grid ni nj, right? Nj minus t, but this might be already a negative value, so we need to do this. We need to do a std maximum of this and 0, okay, and of course ni nj, but we have to get a negative on this, okay, and grid ni nj or equal to -1. So this one is visited, we don't visit again. So we do that, so we get everybody in, and that is about it. All right, that is about it. Well, update all cost depend on the dt. If dt is 0, you don't have to update cost, right? Update all the costs if dt is larger than 0. So essentially here we say if dt is larger than 0, then we need to update all the costs. Otherwise, we don't have to. pq.pop. Forgot that. So yeah, blah blah blah. What else? We need to also check here. Maybe this one need to get higher up. Yeah, maybe this one need to get higher up. Okay, we get this one higher up. So we get this one higher up. ij and j equal to n-1. So we already reach it. Then we just simply break. Otherwise, we go all the way down here. Then we return t. All right, let's give this a go. See how we are doing. Oh, it's as wrong as it can get, man. Okay, let's see. What goes wrong? Oh, very wrong. I'll put 1. How come you get to 1? You wanna debug this? Yeah, let's debug this. Vector int, just int. It's gonna be a grid. What's that? 0213. Wait, 0213. This is going to be, I forgot what was the name. Swim. So swim inside grid. This is going to be 0, 6, 10, 10. Okay, we built it successfully. Where is your, I'll put it here. All right, let's debug this baby. All right, I think it's F2 is going down. So PQ, oh, we have first, second, 0, 0, 0, yes. And grid, where's my grid? Grid, no, okay. Okay, t equal to 0. So ij. Where is I? Where is j? I don't know. dt is 0. T is pq top 0. T is 0. dt larger than 0? No. So pq dot pop. Okay. And huh? Oh, a reference back. That's interesting. So ni reference back, nj, good, 0, 1. So we move to 2. This is good. So t is 0, it's 2. So we should push 2. Negative 2, yes. 0, 1. So this one set to negative 1. Good. Next one. Ni and j. So this is going to not do it. Next one. Ni and j is 1, 0. So we go down. Down is 1. We do it. So we're gonna push in and negative 1. 1, 0. Yes. And then oh, I never updated t, right? I never update t. But we don't need to update t. Ah, I see. I see. This shall be this to do this. I think this will work. You have to get a t first. You can't just break. So we actually, what we're getting is the previous values, not the current value. This shall work. Hopefully. What the hell? What the hell? But 2. Oh, this is bad. This is very bad. Yeah, this is the top. Is like what you need to reach when you get there. Wait, hold a second. Let's do it again. Okay, so that's fine. We go. Was it the last one? 1, 0. Yeah. And next shall be no good, shall be a -1. Okay. Done. Alright, so PQ at the top is -1. So I get IJ out. IJ is gonna be 1, 0. So we are actually here, right? We're actually here. So now dt is top -1 and current t. Oh, you do need to. Yeah, that's okay. So dt is -1. dt is a -1. So that is the cost. So this is the cost. This is the current time. Yeah. I feel this is wrong. I feel this shall be a negative this minus the current time. Not sure. Let's go give it a shot. So it should be negative this minus time. This then dt is positive. Nope. That's alright. Let's try one more time. Get back. Okay, now dt. Huh? How is that possible? Phew, this is 1. Right. One minus 0. How is this? I don't understand. PQ top first is -1. Hold a second. Do you? Maybe you haven't saved this yet. Okay. Yeah, dt is 1. T is 1. That's 1, 0. Okay. dt is larger than 1. Yes. Then we need to get m is 2. So everybody in it need to readjust dt is 1. Okay, so we pop this element. So we 0 and 1, 0 coming in, and next. Oh shoot! Ah, screw me. Darn, I know why. Ah, fuck me. Okay, that's fine. That's fine. We cannot do that, and we cannot iterate through this one as well. So two choices. We create a new one. Yeah, we create a new one. Create a temp. Okay, create a temp. So we say std priority queue. Oh, actually, I'm not sure. Basically, we pop. Yeah, it's fine. Priority queue. Pair coord temp. Now we don't need this. Okay. And we just go while pq.empty. And then we do this, and then we say temp dot push. Once we're done, we say pq go to. We're gonna move temp in here. Okay, does it compile? Yep, it compiles. All right, let's give this another run. What? Okay, I have no idea. This, all right, I thought I fixed the issue. Okay, so dt is 1. Got a temp. Element. Oh yeah, element first is this. So temp will push a 0 and a 1 0. Yeah. And then the second one. Okay, so temp, we have a 0 0 0 and a -1 something, right? -1, this is going to be 0 1. Yeah, the cost is 1. So now PQ, we are going to inherit. Right, PQ going to be this. Okay, now PQ dot pop. Yeah, because IJ is already out. Not sure if that is the reason, but I feel it could very well be. No, not really. Okay, it's fine. Just okay, and we'll do this. Okay, this is fine. Okay, so IJ is 1 0. T is 1. That's good. So N9 and J is 1 1. Yeah, we want to go to 1 1. Oh, I see. Wait, hold a second. The T is not this. DT is the current time. This shall be grid ij, but I already set it to guard. That's actually not good. That's actually not good. Well, I haven't visited. Yeah, t shall equal to this. This is the current time. Okay. How about this one? Alright, this one's not right. 6. Oh, we get there, but we need a total time. How about we do this? Okay. Give this a shot. Nope. Well, I got quite a few correct. Well, I think just by doing max probably is not right. We have a 19. Huh, interesting. Oh, I do still need to have not visited. This is the it's not visited, it's the min cost. Oh, main cost is negative, grid 0 and 0. Right. So again, here is the trick. If actually we can get all this out. Ij and cost. Right, this is the current cost. If cost is not equal to mean cost I times n plus j, and we will do pq dot pop, continue. Otherwise, we'll do cost minus this, and then t will be the maximum of this. That's actually not right. Cost. Is the additional cost. So maybe hold on. Hold a second. The dt doesn't feel right either. We already put... This is the cost to reach there. So it's already a dt. So dt, I think it's already cost. I think cost, this is dt. Right? This is delta t already. So you don't need delta t again. And t shall equal just, you know, plus equal to dt. So this is the mean cost. If the current cost is smaller than mean cost, right? So the current cost is smaller than mean cost. Oh, I need to 28 max. What is the current cost? I don't know. So current cost shall equal to this then. Right, this is the current cost. Not recurrent cost, the next cost. Right. So we say the next cost is smaller than this. Then say pq dot push next cost and the main cost. Okay, how about this one? Yeesh. The hell? 0. Maybe it is right. Oh, wait, hold a second. Mean cost. Make them positive values. I don't know. I'm trying again. Yo, coming back to 19. Not sure. Oh, I did it in the past. Oh, shoot. Alright, I don't know. Oh, I have to... Oh my goodness, I cannot. Let's go here and just submit this one. DSU. What? What in the world? Dijkstra doesn't work. Have to use DSU? Wait, do we have a not DSU one? Binary search. Let's use this one. This is how I imagine it, right? As a heap. Copy and paste. You see, this is just +1, so we can avoid a lot of the issues. Okay. If we just grow the t, if we just grow the t, so we don't do this, it's like every time we just grow t and we check. See, oh good, so we go in, and now we have this and this, so we check, which is good. It's the smallest, coming up, and then we do this, and we check. So what do you mean is we don't even have to get a min cost. It's just a BFS. But we do have to get a min cost in, and then when it hits, then we just get out, and then if it's not good, we just keep going and keep going, which means I don't need the min cost. So this will become visited again, right? This will be just visited. So make sure we don't go back. Okay. So we say this is visited. And then this is gonna push. Yeah, still this push in. So we just say visited 0 equal to true. Okay, we have t. Well, this ij cost, I'll call it cost. Right, the cost. And we say if cost is smaller or equal to t, right? If cost is smaller or equal to t, then we can, if cost is smaller or equal to t, then we can do what we need to do. Well, basically put the entire thing. Oh, hold a second. I think we need to. This is the last attempt. If this doesn't work, then we're. We use a priority queue, a min heap, right, to keep track of the earliest cell, right? We have to have the cell that the cells that are currently available, right? Currently available. We tick the time t up, and once t is larger or equal to grid ij, we can visit ij. We BFS the whole grid until we reach the end. So yeah, we have this. If it's smaller or equal to cost smaller or equal to t, then we can say we basically do this part, right? We'll pop it for this and so on this, and visited ni times n plus nj is not visited. Right, we don't even need to consider this. We just say this is gonna push grid ninj. It's much simpler, right? And then this is going to be visited. This will be true, right? So this will push this in, and we'll go off all of them. Get out t++, and all of this. I mean, my initial attempt was just trying to not go by t, but I guess you have to go by t. That is not right. 25. What the hell? Negative. Still not right. The hell, man? Cost is smaller or equal to t. Yeah, that's when we can visit it, right? Cost is smaller or equal to t. Then we will pop it. And then we go through DIDJ and push them in. I don't know. Where do we go wrong on this? And if the cost is larger than t, then t just into plus plus. Oh, where is the check? Where is the check? Sorry, I forgot. I forgot a check. Oh, break. Okay, this is right, but this is wrong. So basically this gets the largest. 26? What? Oh, I see. When I get them in, the time tick. You should get all of them out and then tick the time. Everyone that can get out need to get out at the current time. Which means you need to check everyone, right? You need to check everyone in this. And then, so we do need a temp. Yeah, it's just like one round, right? Okay, so we do need here. So basically, we will get that it's the current time. I'll check which one can get out. So I'll get all of them out into a new one. Right, this is the new, so like if it can get out, then we do it, we push in a new one. If it cannot, then we just add it to it, and then we swap. Okay, so essentially what we need to do is, it's not even this then. Yeah, I just go through everyone. Right, I just go through everyone, put it into new one, so we can get something where we get out, and then those will get to the other one, and then what's the point of using a priority queue? If you're gonna go through everyone, what's the point of using priority queue? You might as well just using a deck. Now the priority queue, so you can just check the smallest. If the smallest is bad, then you don't even need to do it. Right, but if the smallest is good, like in this case, smallest is good, and then you can you have to go through them. You will do this until you cannot, right? You'll keep doing until you cannot. So essentially what we want is this need to be a while loop. While minus pq dot top first is smaller, so while pq dot empty and is smaller or equal to t, right? Then we check int I is pq dot top dot second dot first j pq dot top dot second. So huh? What the hell? Oh, my bad, this is top. So grab ij and pop this, do this until we cannot do, then we do this. Okay, if this still doesn't work, then we'll just do it some other time. What the hell? Yeah, everybody can get out. We'll get out, right? I don't understand. T is 1. Oh, I see. Wait, no. Wait, yeah. Wait, hold on. T is 1. Yeah, it's fine. This one got popped. Three comes in. Okay, so we have minus. So PQ is minus 2. So is 2 smaller than no. So we get out T equal to 2. Right, so this is now 2 coming in. 0, 1. And then none of this shall. Yep. So now it's 3. No. Oh, break. Alright, so I think reached false. Just, you know, put together different types of solutions. What the fuck? Okay, so this seems to be just off 1. Oh, yeah. Because this T++. That's fine. We just do a check here. If reached, no break. Yep. What should I say? I don't know what to say. It's not hard. It's just I'm curious of all the other solutions then. Alright, that'll be it. I'll see you guys tomorrow. Adios.